What we forgot to discuss on Friday was how do you get reference angles for when you're using radians. So I'm going to show you the long way, and then I'll show you a shortcut. The reason why you have to use the long way is because you cannot always use the shortcut. So when we started out, I'm going to write in for degrees what it would be. So degrees would just be theta, then it was 180 minus theta, theta minus 180, and 360 minus theta. Correct? Yes? So this is 0, this is 90, this is 180, this is 270, and this is also 360. Now, in radians, this is going to be 0. Does anyone remember what 360 is? One whole circle is 2 pi. Okay, what's half of 2 pi? Because half of a circle.
Wait, I have a question. Why is it 180 minus theta and theta minus 180?
Can I just put these around and then I'll show you what the difference is? Okay, so this is pi. So 2 pi, we start with 2 pi. Half of that is pi. So half a circle is that. What's half of pi? Because that would give us the quarter of a circle. Pi over what? Pi over 2. So 90 is the same as pi over 2. And then we can see this is 1 pi over 2, 2 pi over 2, which would be pi, 3 pi over 2. So I wrote both the degrees and the radians here. So basically, wherever there's, so theta is going to stay theta. Wherever there's a 180, what am I going to put instead of 180?
Theta, or pi.
In radians, it's pi. So I say pi minus theta. Theta minus what? Instead of 180, I can put pi. And 360 is the same as what? 2 pi, so I put 2 pi. So the top is if I'm dealing with degrees, the bottom is if I'm dealing with radians. Okay? Andrew, to answer your question, in this here, remember this is the angle theta. If we want the reference angle, that would be this red angle here, right? So we take half a circle and subtract the gray area to get the red area, right? Does that make sense, right? So for the bottom one, I'll just draw another little coming off right here. Now my angle is over here, correct? This is the gray area, which is theta. I want the red area, correct? Do you see that this part here is how much extra? It's 180 extra, so I take the whole gray area and subtract half a circle to get my red area.
So that would be like 195 or something.
Correct.
Okay.
Okay. So now I've given you these. So let's, and again, if it's over 2 pi, you have to subtract 360. I'm sorry, if it's over 360, you have to subtract 360 to get it between 0 and 2 pi. Same thing, if it's over 2 pi, so say it's 5 pi, you have to subtract 2 pi until you get it between 0 and 2 pi. Okay? Now, let's say they give you an angle, 7 pi over 6. Okay? So to find the reference angle, what I think of is this. Alright, so I just think of the angle, I think of 7 over 6. Okay? 7 over 6. Is that greater than 2? 7, 6, is that greater than 2? No, it's not greater than 2, right? Is it greater than 1? Yeah, is it between 1 and 1 and 1.5? Okay, so that means it's going to be in the third quadrant. So I can say, okay, it's going to be in quadrant 3, because it's between 1 and 1.5. Why do I say 1? Well, because this is 1 pi and this is 1.5 pi. So I'm just looking at the fraction in front of the pi to make it less confusing. So then I say, alright, well that means I got to put the angle minus pi. So I say 7 pi over 6 minus pi. Right, but you have to have a common denominator, so what do? 6 pi over 6, and what does that give you?
1 pi.
So, let's say we have, this is an example 1. Let's say we have another example. And we say, alright, let's say our example is 10 pi over 7. Okay, so I'm going to look at 10 sevenths. Is 10 sevenths greater than 2? No, so I'm fine. I don't need to subtract 2 off, okay? Is it greater than 1? Yes, so I know that it's either in the third or the fourth quadrant. Is it greater than 1 1/2?
No.
No, right? Because 1 1/2 would be 10.5, right? So it's in quadrant 3 then, because it's between 1 and 1/2. So it's in quadrant 3. So again, I use quadrant 3's, which is theta minus pi. So that gives me 10 pi over 7 minus pi. But you have to use common denominator, so 7 pi over 7, which gives me 3 pi over 7. Okay, now, fortunately for us, so what I want to show is that if it's over, sometimes when it's over a number, you'll get like 3 pi over 7, or you get some answer, alright? Fortunately for us, when you have the angles that we use all the time, which are pi over 3, pi over 4, I should say pi over 6, pi over 3, and pi over 4, this goes with 30, 45, 60. So these are our special angles, right? Fortunately, every time you do the reducing, you're always going to get just pi over whatever the denominator is. So if it's ever over 6, 4, or 3, the reference angle, this is the shortcut, is pi over whatever the denominator is. So my point was to show you that it doesn't work if it's like over 7 or over 5 or over, 9 or whatever, but it's special that it only works with these, and luckily for us, these are the ones that we use all the time.